We're given these two isotopes of element called cadmium, and it's an absolutely fictitious element, so that's why I can't pronounce it, but it's got an atomic number of 165, and then there's two differing mass numbers of 311 and 313. They tell me 74% of the sample is the 311 isotope, and the remainder, that means 26%, must be the 313. So I'm going to go 0,74 times by 311, 0,26, that's the other 26%, 313, and I land up with 230,14 and 81,38, and therefore I land up with 311,52. The element boron has an atomic number of 5. It occurs in nature as two isotopes with 10 and 11 respectively. These two isotopes occur in a ratio of 1:4. 1:4, if I'm looking for percentages, is 20:80%. That is a 1:4 ratio, and these would then be percents. So they say that 10 is the isotope that is more abundant. So there must be 10, and so the 11 to 10 ratio is 20% 11 and 10% 80, because they've told me that there's more of the isotope 10. And then determine the average. You might want to work on that. And we get 0,8 times by 10, 0,2 times by 11 is equal to 8 and 2,2. So my answer turns out to be 10,2. Explain why the relative atomic mass of carbon on an accurate periodic table is not exactly 12. Most of you got 1 mark on this, but you didn't really quite get it down to the button, so pay careful attention. Firstly, you needed to say carbon had many isotopes. The most abundant of those isotopes is 12, but there's a little bit of 13 and 14. These need to be considered in getting an average, and it's a percentage average. Even though they are a very small percentage, they do elevate the relative atomic mass slightly. And what you need to do is you need to say that these each make a contribution in the percentage that they naturally occur. That's what needs to come across. So contribute in percentage that they occur would be quite a nice way of adding to that. Defining relative atomic mass, this is just a definition, and you need to put this into your list of definitions. It is the ratio of the average mass per atom of naturally occurring form of an element to 1/12 of the mass of carbon. I can make this 3 marks. It's an average mass of atoms naturally occurring when compared to 1/12 the mass of carbon. All the others are short, or they've got something extra which isn't true in it. So your correct answer is going to be A. Define an isotope. It is when you've got the same atomic number but different mass numbers. So let's go through this. One of 2 or more atoms having the same atomic number but different mass numbers. That looks like a very good definition. The others are all going to only have part of that information or something that's completely false in them. Write this definition down as something that you need to learn. We've now got chlorine. It occurs in nature as 75%, 0,75 of chlorine 35, and 25% of chlorine 37. And what have we got as an answer there? We find that this is 26,25, and this is 9,25, and therefore my answer is 35,5.